Hello, and thanks for checking on our poster presentation at the IRA workshop at CBIR 2020. Before we start, I would like to point out that this is a 5-minute abbreviated version of a full contributed talk we gave at the workshop. Please feel free to move over to the full talk as it covers all contents in this poster presentation. Here we present Syntharch, an interactive image search method that uses scan synthesized images instead of textual queries to collect relevance feedback on attributes for content-based image retrieval or CBIR task. A key challenge of the CBIR task is to bridge the gap between the user's high-level concept and the machine's low-level representation of images. Indeed, in traditional web search, users issue text queries which need to be understood by the machine to return search results. In order for the user to issue fine-grained queries, researchers have studied interactive search, which allows the user to provide additional information regarding the target iteratively, and it has been established that semantic relative attributes can facilitate the refining process. For example, search system can set up filters, ask for relative comparisons based on the attributes. However, using textual form of the feedback requires the machine and the user to understand these attributes in the same way. So what if we don't have those attributes? What if some attributes are so loosely defined that they cannot be accurately yet concisely expressed in words? To address these challenges of interactive image search, we propose Syntharch, a new way to close the semantic gap using visual-only feedback on high-level attributes. As shown in the diagram on the slide, after the user starts the search, synthesized images that differ in attribute values are presented to the user as options. And when the user makes a selection that one option is closer to their target than another, the system can then incorporate that feedback, re-rank the images, and possibly continue with more questions. Syntharch leverages conditional image synthesis for collecting more informative feedback. It comprises two modules: a preprocessing module that performs a two-stage training for every image database, and a search module that interacts with a user who wants to retrieve an image from a preprocessed database. In training stage 1, we train 3 networks for attribute condition image synthesis. At the time, we learn a multidimensional attribute space where each dimension corresponds to an attribute. This model is adapted from RankSequence introduced by Zac Yu and others in 2018. Then, in stage 2, we train an encoder network to find estimated attribute vector and the latent noise vector to enable image editing. Finally, we use range searching combined with relevance prediction to generate the candidate options and to re-rank all images after each search iteration. A sample question shown on this slide comprises of 3 images, the target image to search for, and 2 options labeled as 1 and 2. In this particular case, I would say that option 1 is closer to the target compared to option 2, so I will choose 1. Questions like these are used for our experiment, where we ask up to 12 questions for each search iteration. For our experiment, we want to evaluate the benefit of image editing and the benefit of range-based search. So we compare the performance of our method to that of the alternatives. From live experiment session of 80 search sessions per method, we recorded a total of 2,876 relevance feedback responses. The plot on the left shows the change of the search accuracy measured by the percentile rank for all 3 methods as the search progresses. We observe that the rank of the target image over time for the Syntharch method, represented by the blue line, exhibits the most consistent increasing pattern and has the highest rank percentile among the 3 methods. We concluded that Syntharch method is more likely to perform better than other alternative methods by the end of the 12-question search, as well as for most iterations, validating both of our initial hypotheses. Nowadays, interactive image search systems rely predominantly on attribute labels and comparison feedback in textual form. In this work, we explored a novel approach using only visual feedback to accomplish the same task. Thanks again for stopping by for our poster presentation. If you are interested in our work and want to learn more about it, we invite you to join our full talk where we will elaborate on the details of a method, discuss strengths and limitations of work via case studies, and touches on future work and more. I hope to see you there.